Hello everyone, here the topic of my report today is a trajectory, driving force, and mitigation potential of energy-related greenhouse gas emissions in China's primary aluminum industry. I will complete today's report from four aspects. The first is background and significance. The second is methods and the data sources. The third is results and discussions. And the last is conclusions. Background and significance. The figure shows the distribution of CO2 emissions caused by fossil fuel combustion. At present, China has become the world's largest emitters of greenhouse gas. As one of the major global greenhouse gas emitters, China has become working hard to reduce its emissions. At the Paris Climate Conference in 2015, China promised that its total CO2 emissions would reach a peak around 2030. Recently, China reformed the commitment to reach its CO2 emission peak before 2030, and has also set a new goal of achieving carbon neutrality by 2060. Aluminum is widely used in modern technology. With increasing industrialization and urbanization, the demand for primary aluminum in China has also increased. In 1990, China's primary aluminum output was only 0.8 trilogram, accounting for 4% of the world's total output. However, China has now become the country with the largest aluminum production and consumption in the world. In 2018, the primary aluminum output reached 37 in China, with the shares of the total global output rising to 57%. Primary aluminum production is one of the most greenhouse gas emission intensive industrial process. The total greenhouse gas emissions of China's primary aluminum industry was 420 TG in 2030, account for about 5% of the country's total greenhouse gas emissions. China's primary aluminum output is limited to increase and may exceed 45 TG in the future. And the corresponds greenhouse gas emission of China's primary aluminum industry will also increase. Therefore, this study attempted to quantify the greenhouse gas emission triggers, identify the driving force of its rapid growth, and the mitigation potential. Method and data. As a complex basic industry, there is a large amount of raw material and energy exchange between the aluminum industry and other industry. Primary aluminum protection is mainly composed of 5 protection units, namely bacterial mining, aluminum refining, carbon anode protection, aluminum simulating and ingot casting, and recycled aluminum mainly includes collection, selection, transportation, pre-treatment, simulating, and casting process of scrap. The source of greenhouse gas emission can be divided into directly and indirectly emissions. This table presents the various emission sources. Firstly, we employ the time series data to imitate the greenhouse gas emission under the LCA framework. Besides, we calculate the historical trajectory. Secondly, the LMDI was used to identify key factors influences the growth of greenhouse gas emission and quantify the effects of such a factor. We decompose the greenhouse gas emission into 5 driving force factors: the energy emission factor effect, the energy structure effect, energy intensity effect, process emission factor effect, and protection activity effect. Relevant whether whenever improving aluminum protection technology can offset the increasing in greenhouse gas emission brought about by the growth of aluminum protection activities. If not, which effect is the key to reduction greenhouse gas emissions? Detailed information on the greenhouse gas emission of this study is present in this figure. Notably, the greenhouse emission factors have shown a significant driving trend over the past 13 years. Moreover, it can be roughly divided into 3 periods: steady decline, accelerate decline, and slow decline. Due to the limitation of the data and methods, 3 are some differences in result of previous study on the greenhouse emission. The assessment results for greenhouse gas emission factors of Ding, Zhang, and Peng are similar to those of this study. This figure shows emission. The greenhouse emission trajectories and the propagation from the different sources are shown in this figure. Notably, the total greenhouse gas emission have experienced explosive growth, accompanied by a PAP boom. During the investigated period, the total greenhouse emission increased by approximately 18 times. Among all the sources, greenhouse gas emission from electricity, coal, and anode consumption contributed the majority of the total. In this study, the Sankey diagram method was applied to present a historical picture of greenhouse gas emission follows the width of each line represents the greenhouse gas emission driving stream of the industry chain. The construction sector was the largest embodied greenhouse gas emission sectors. Other embodied greenhouse gas emission sectors mainly include the transport equipment, electricity equipment, consumer durables, machine equipment. The result shows that the order of the intensity for the driving force, the protection active effect has the most obvious positive effect. on the growth of greenhouse gas emissions, where the energy intensity effect has the most negative influence effect. The energy structure effect is also a positive factor, but its contribution is low compared to the protection activities. The scenario analysis method was adopted to assess the emission trend and reduction potential, including the business as usual, emission factor, energy intensity, energy structure, and comprehensive scenarios. The three emission reduction scenarios can effectively reduce greenhouse gas emission and the order of their mitigation potential from high to low in the energy structure, energy density, and emission factor scenarios. The main findings of this study are as follows. First, the life cycle greenhouse gas emission factors of China's PAP has been dramatically reduced in the past 14 years. For technological advancement from approximately 13.1 to 13.1 ton CO2 equivalent aluminum. Second, the results of the driving force analysis show that the protection activity effect is a leading force for the increasing in greenhouse gas emissions, while the energy intensity effect is a major contribution to their decrease. Third, the result of the scenario analysis demonstrate that the abatement potential of greenhouse gas emission 4, 6, 11, and 20% in 2013 under the emission factors, energy density, energy structure, and comprehensive scenarios compared with the BAU scenario. Some measures for mitigation greenhouse gas emission are as follows. 1. As the explosive growth of the primary aluminum output has promoted a dramatic increase in greenhouse gas emission from China, the simulating quantity of electrolytic aluminum in China should be controlled. 2. Optimizing the energy structure is an important and feasible method for reducing greenhouse gas emission from China. The propagation of electronic aluminum based on clean energy in China only account for 10%, while potential in North America, South America, and Europe has researched 83%, 7%, and 19%. The energy density of China's primary aluminum industry requires further reduction. Also, the energy density of aluminum refining and primary aluminum simulating has been reduced significantly from. It is still not up to the advanced international level. Thanks.